Malaysian 370, contact Ho Chi Minh 120.9. Good night.
Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
From the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds."
What up, everybody? Welcome to the live stream tonight. Hope you guys are doing well. I'm Ashton Forbes. Guys, first of all, I saw a little Pop-Tart in the chat. Thank you for being here, everybody, or little Pop-Tart and everyone else. Guys, we've learned a lot about zero-point energy, about anti-gravity, about physics beyond the paradigm. And tonight, I want to learn a little bit more. I want to dig into more about magnetism, magnetic river with Eric Laithewaite. Before we do that, we have 2 quick agenda items that we're going to get into. It's okay, girl. Number 1, merch is still on sale at Skunkworks HQ. 4 Orbs merch. Check it out. I've seen a lot of people getting it. I've got a lot of it. It's awesome. Number 2, the agenda this week. We're going to be looking at Eric Laithewaite today. It's going to be really exciting. And then there is going to be MH370 for the rest of the week. Saturday is the anniversary of the disappearance of the plane, the 11-year anniversary. So I decided, okay. And then I probably will add the evidence stream to the podcast. So on Wednesday, I will have an updated evidence list and go through it and update whatever else in real time. On Friday, I will go through the theories. And when I mean this, what do I mean? I'm going to go through, like, what are the other investigators saying out there? And I'll try to hit as many as I can, but predominantly like the whisper analysis where they're searching right now compared to some of the other evidence out there and why certain theories are stronger than others. So full week of MH370 content after today. Okay, guys. Before I do that, I just kind of want to riff for a second because I was watching some of the Eric Laithewaite stuff, and it just, if you've been following along for a while, like we have essentially, I think we've kind of put all the pieces together. Like, what has been figured out? Well, UFOs, maybe they're alien in origin, what have you, but humanity has figured out gravity, and probably the easiest way to produce it is plasma. And they've figured out how to manipulate, control, shape plasma with magnetic fields. So today's stream is going to dig more into that. And hopefully we'll piece a lot of it together. Okay. Let's just get started. Which video do I want to show first? First, I want to start with just this introduction video with a shout out to Professor Simon Holland, friend of the show, and also just good guy. I'm just a big fan of him in general. I like what he does. I like it that he puts himself out there. I like that he's not afraid to give his opinions. So here's a quick intro video that he did. You can find the link in the chat about Eric Laithewaite. Here we go.
I always assumed that my hero, Eric Laithewaite, the engineer...
Real quick, I didn't know that he was a hero, that Eric Laithewaite was one of Professor Simon Holland's heroes. I did not know that. So I learned something today.
Engineer and scientist was excluded from the physics community because what he said about Isaac Newton, gravity, and centrifugal force on a BBC Royal Society Christmas lecture to children. Let me read you now what this viewer sent me, and you can make up your mind. Eric Laithewaite, not so crazy after all. He never was crazy. It is now nearly 10 years since Henry Wallace, American inventor, was granted a pair of patents on what was initially written off as a crazy science fiction notion, a machine to generate anti-gravity. It goes on to say, in the last 10 years, Professor Eric Laithewaite of Imperial College London has achieved both fame and notoriety, sadly, by arriving independently at a similar theory of anti-gravity. According to Wallace's patents, bodies made of carefully chosen materials generate an energy field when placed in rapid relative motion. This field is not electromagnetic and was christened by the inventor a kinematic force field. Wallace and Laithewaite stated.
Okay, so in this patent, basically they're saying it's a non-electromagnetic force field. When they're saying kinematic, they're meaning kinetic in nature. So it's like you can feel the force of it, a kinetic force. And then they're saying that they can be produced through rapid acceleration. Now, this sounds a lot like what Salvatore Pais has been saying with accelerated spin and or vibration. There are some striking similarities in some of the science between some of these guys that I'm going to be pointing out all stream long. In fact, that's kind of the whole point of the stream. So hopefully that's why you're here.
That if this kinematic field is made to undulate. Now, remember, Eric Laithewaite is the father.
Undulate would just mean, right?
Of undulating river of electromagnetic force called the linear motor. So Eric knows what he's talking about. So if it's made to undulate, a secondary gravitational field is produced which can neutralize gravity. Okay. All right. So
wow. So back in the 70s, Eric Laithewaite was saying, if we manipulate the electromagnetic waves, we can tap into gravity, the underlying source of gravity. Woo, chat. When I heard that with Professor Simon, my ears perked up. I went, oh boy. Eric Laithewaite figured out 0-point energy way before, even before anyone knew what 0-point energy was. It wasn't even called 0-point energy back then. And he understood that there was a relationship. So, you know what's getting crazy? I understand why people think I might be egotistical or what have you, because we're so over the mark right now. It seems like someone's just like, how could you possibly know that? It's like, well, we've done the research now and we can basically figure out, like, when we watch stuff that's legit, we can tell right away. It's like, okay, who is Eric Laithewaite? He was a professor. He was electrical engineer. He was highly established and accredited. And then all of a sudden he falls down this rabbit hole where he realizes, oh, wow, there's like some weird phenomenon happening with spin. And it seems like it's anti-gravitational. Now, why does he call it anti-gravity? I'm just going to say this at the beginning. I'm probably going to say it again. Why are we calling it anti-gravity? This is super important. Why? Because the problem in physics is the concepts. We're not understanding the concepts. It's not the math. The concept's the problem. We need to understand that anti-gravity is just a force that counteracts gravity. If I have 1 unit of force going this way, a counteraction is 1 unit of force going that way, or 1 unit of force going this way, 1 unit of force going this way. Gravity's going this way. We need something going this way, or vice versa, however you want to think of it. Sometimes in physics, things are backwards. That's it. We're not actually like shielding gravity, although in a sense, you could kind of argue that you are, because to think of it accurately, we're displacing ourselves in a bubble. We're not manipulating us, the region around us. Now, that region around us could be very thin, or it could literally be a bubble. But if you displace that region, then that's how you manipulate gravity, inertia, mass. Okay? Anyway, let's keep going.
There's a lot going on here, Eric. I'll include the link to this whole article in the video description. It goes on to describe how it might work using invention and possibly working on an anti-gravity centrifugal device with a colleague from the USA. And did the established science community of the Royal Society and British scientists exclude him because they thought anti-gravity was bollocks? But in fact, today, the spin of near-field subatomic particles has now gained traction and might well be on its way in the public domain to produce anti-gravity effects for the good of humanity. But in a secret and darker reality, has our military produced a gravity shielding device, a mechanism that might be able to reproduce the 5 observable effects of possible ETs UFOs?
Okay. So, first video down. Can't call it. Look, guys, the primitive approach, the low IQ terminology is anti-gravity, right? Like, that's like on the line of like border, mental retardation, right? Like, that's you don't want to be calling it anti-gravity or anti-gravity. It's not anti-gravity, it's gravity manipulation. That's the fine wine, like Pepe with the monocle on. It's gravity manipulation. We're not anti-gravity in the anti-gravity. You wouldn't call it like getting water out of the ocean. Like we're anti-watering that ocean. No, you just feel like I'm pulling water out. Like, what do you mean? Of course the water fills in. That's what water does when you pull water out of the ocean or out of the lake. So gravity manipulation, chat. That's what the pros are calling it. Okay. Now, which video next? You know what? We're just going to go straight into the Dazzle video. It's Razzle Dazzle time, chat. So this video, just absolutely incredible. It's actually, I don't think this is even the one. This isn't even the one that I think I was sent initially. This video is called Professor Eric Laithewaite, Motors Big and Small from 1971. This is the video you need to be watching, okay? This video is going to connect together everything that we need to understand from everything we've learned on these live streams for the last year and a half to where we're at right now. This is going to piece it together and give us the historical context for how this technology has been developed. Okay. So first thing he does is he shoots this cool thing. Here we go. Well, wait, hold on. We want to see it. Let's see it.
2, 1, fire.
So basically, don't mess with somebody who's got a railgun. I'm pretty sure that's what that is. Isn't that what a railgun is, chat? Electromagnetic, propulsion. Yeah, they were just shooting stuff across. This is in 1970s. Okay, so here we go. Teach me, Eric Laithewaite.
This is a linear induction motor. It uses about 100 kilowatts. And it can accelerate 4-pound missiles such as this up to nearly 100 miles an hour. Ready again, Barry? Yes, Rob. Fire. This is a big motor.
Okay.
On the other hand, in this thimble, I have the rotors of over 10,000 electric motors. And nobody is going to deny that these are small motors. Now, a linear induction motor like this is an easy thing to understand because it's just like a flowing river. This is a river bed. If I dip a piece of wood into the river, turn on the water, the first thing that happens is that the wood floats. It rises up, and then when the river is flowing nicely over the weir, I let go of the wood, and it soon attains the same speed as the water. If, on the other hand, I dip into the river a cylinder like this, which is free to spin, then...
Okay, chat. What do you think's going to happen with the cylinder that goes in the water? Okay. So, number one, we have to think of 0-point energy like water. We're in a medium. We're in an ether of energy. It's a liquid of energy. We float to the surface. We're on the surface of it. How similar is this to what I've been saying for the last year and a half? Is that the 0-point energy, the sea of energy all around us that we can tap into, we are floating on the surface of it. The surface is what? The surface is our three-dimensional reality. That's the surface. We're on the surface everywhere, all the time, all around us. The energy is invisible to us, the same way magnetism is invisible to us, but it's there. It's there, chat. So I'm going to go back to this. I want you to put, I'm going to actually make you guys answer. You can see the spinning little wheel that he put in the water here. What direction is it going to go? Is it going to go to the left or is it going to go to the right? Right? He puts the plate on the, if he puts the plate on the water and it flows downstream, what's going to happen with the wheel?
I dip into the river a cylinder like this, which is free to spin. Then the river spins it, and notice which way it spins. The water passing underneath it causes it, as it were, to roll backwards. Now let's look at this linear motor, which is just like a bit of the big machine we've just been seeing.
Pretty cool.
And this is like a river too. In this case, I'm going to put in a magnetic piece of wood, which is a piece of aluminium. I turn on the current, which is like turning on the water, and the magnetic wood floats. When I let it go, it soon attains the speed of the river. But of course, in this case, the speed of the river is much greater than was the speed of the water. Again.
Okay, I think already this is hugely important. If you already aren't going like, okay, we're on to something here, like you probably haven't been watching enough of my live streams, because like this is here a situation where it's like you can look at this and you can say, oh wow, like look at the power of this phenomenon. Already, what have we seen? We've seen that magnetism is powerful enough that it can shoot something at a very high velocity. We've seen that it can work forward and backwards. You can use the flow and you can work against the flow if you want, or with it. Go both possible directions. And it can levitate a metal. Literally just levitate it right above. So right off the bat, you can see why Eric Laithewaite was into this. He knew something unusual was happening here.
And if I dip a cylinder, this time a copper cylinder, into the magnetic river, it spins in the appropriate direction.
And look at that. You just put your cylinder over the river and expectedly it's going to spin. Just start spinning. Of course it will.
We can have a shallow river. There is a shallow river. Or turn on some more water. There is a deep river. When I'm making these comparisons, I'm doing what every engineer does almost every day of his life. I'm using an analogy. Now, a good engineer knows when to use.
So the analogy is that 0-point energy is a superfluid medium that permeates all space-time. So 0-point energy is the background of our reality, and it's always there. We just don't realize it's there because we're sitting on top of it. We pretend like it's not there, but the experiments show that it is there. The refutation of the Michelson-Morley experiment that I showed you today that shows that if you reinterpret the ether and the ether wind as the ether wind being gravity, then you do see the exact phase shift that we would expect to see based on altitude, which is where gravity changes. So again, the answer to the problem has been a matter of us just not looking at the experimental results that we're seeing with our eyes and then applying, changing our conceptual view of universe to match it. I want to do a couple super chats. We are the change. Brother, you've always been on fire. Thank you very much. Appreciate it. And then Mark Scott, man, thank you. Wow. I really wish we would pull the rug on this. Talk about 0 point energy, then show an egg being rolled on the ground, wrapped in a tablecloth. I think that the best we can do is continue to explore the science and teach people about the science, because people aren't talking about Eric Laithewaite. Thank you very much, Mark, for that huge donation, man. People aren't talking about these scientists because they've been discredited because, oh, we're going to find out here in a moment that Eric Laithewaite said that, well, this spin phenomenon that we're going to look at here in a second, which is absolutely proven, it can't be explained by Newtonian physics. And he was wrong. It can be explained by Newtonian physics. That's not really the point. But they use that to discredit him and said, oh, well, he was wrong about this. It can be explained by Newtonian physics. But it's not that it can or can't be explained by physics. It's something that's counterintuitive. That's what's important. It's something that doesn't conceptually make sense to us. But yes, if you look at the math, it says, okay, well, I guess technically this works. So that's what we're going to be looking at here. And that's what I love about watching this with Eric Laithewaite, because you're looking at him, he's going, he's an engineer. He's not a physicist. He's an engineer. He doesn't give a shit about which model you care about the most or who your favorite physicist is historically or who you agree with most. He's like, dude, I'm just making crazy shit here. And to me, he's like, I can imagine being Eric Laithewaite looking at that and going, he almost certainly realized that free energy was possible. Like, no question, no doubt. Just a matter of how to engineer it. Okay, last super chat. Julio, if you send blue green-eyed algae to Mars and use plasma orbs to accelerate their growth, it would kickstart Mars' atmosphere the way it did. Yeah, probably. But if we have free energy, we don't need Mars. This is the funny part, is that this is why, and I'm not to put you down, Julio, because I love your super chat and thank you for the donation, but a lot of people out there, even though some of you, are thinking too small. Frankly, thinking too small. The jump we're about to make as a species, this is the problem that the reason why people can't really come to terms with all of this is that the jump is so big compared to what we would be expecting, right? Like, we're down here and we're expecting to make this like jump up here, right? And be like, oh, we got this alien technology. It jumped us up to here. No. This 0 point energy technology like obsoletes all our previous goals for space travel. You wanted to go to Mars? Why? Who gives a shit about Mars? We can go anywhere we want. There's already planets out there that are perfect. There's already another Earth out there that's 5 times bigger than this Earth that's absolutely perfect for us. All we have to do is find it. We can just teleport there. Boom. You can live the rest of your life there. That's where people are like, this technology is going to take us from down here to like off the scales. That's how much of an advancement. That's why people can't grasp it, even though the science is right there in front of us. This is the part that the thing that keeps me up at night, guys, isn't the government killing me, the CIA, aliens existing, aliens anal probing me. None of that stuff's what keeps me up at night. What keeps me up at night is that humanity is so stupid that it's me, a fucking IT guy, healthcare IT guy off the streets, that has to be the guy that pieces it together, all the shit that's already out there, that some of it's been discredited or ignored, what have you. There's, I don't know, take your pick. Basically, it's just a shit show. Academia is a shit show. Academia is just as bad as the UFO community and all these other communities that are infiltrated with politics and bad faith actors and just people that do nothing and just leech. It's all a shit show. And it just took somebody coming off the streets that's just like, you know what? I don't have any vested interest in all this. I just want to get to the answers here and figure it out. And the only thing that I had was 2 videos that just showed, oh, this is the answer. If these videos are real, well, what's the answer? And oh, it turns out here it all is. It's been sitting out here. Nobody else has really figured it out. So that's the world we live in, chat. That's the world we live in right now. Okay. Let's get back to this. I didn't think I'd have a rant that early on tonight. I really didn't. Okay.
Use an analogy and where it breaks down. And I'm going to show you where this one breaks down. If I take a heavy cylinder, such as this, and place it in the river.
Okay, here we go.
And then turn on the water. You see the flow rolls the cylinder downstream.
Huh.
If I now place the same cylinder in the magnetic river and turn on the magnetic water, it rolls upstream because you see the river is flowing that way. It doesn't matter whether I use a small cylinder or a long cylinder, and these are all of copper, or whether I use a steel cylinder, they all roll backwards. A steel ball rolls the same way. So does a steel washer. Of course, you can have a lot of fun with this. This all-plastic motor car has had 4 steel wheels fitted. There's the engine. And when you release it, it goes quite nicely.
It's like, okay, you watch that. How can anybody watch this car literally being driven on an electromagnetic river? So he's basically created a magnetic river. That's what we're looking at right here, right? So you watch this and you go, wow, this is the basis for maglev. If you guys know about magnetic levitation, like maglev trains, or even like, depending on how you think the cars fly in Back to the Future, could be some sort of magnetic levitation. This is the basis for it right here. Is if you just made the roads out of magnets, you could do this. That's the idea, the Hyperloop. Make the roads out of magnets, and then you can do this. Now, the analogy breaks down because in water, if your wheel is not built the right way, it doesn't work. It doesn't work. That is a very profound idea that's being overlooked by a lot of you right now. So I want you to think about this. Realize in the situation where he took the tube and he just took his tube and it was spinning around, it depended on how it was engineered, determined how efficient it was going to be for what we were trying to get it to roll, basically. So that's also true of how we're interacting with the 0-point energy. It can depend on how efficient it is. But in the case of the 0-point energy, the reason why we don't have the problem that we have with the water is that the 0-point energy is all around us all the time. So no matter which thing we use, they're all going to flow the same direction, unless you were to manipulate the 0-point energy. If you were to manipulate the 0-point energy, then what would happen with the car that we're looking at right here? If you were to manipulate the 0-point energy, you would cause the car to ride off the rails. If you manipulate the 0-point energy on the left or the right of the path, you would cause the car to deviate one direction or the other off the path. So that's the reason why it keeps going straight. Okay, here we go.
Now, why is this? Why do all these pieces of metal roll backwards along the field? To understand what's going on, we need to look at the shape of the field lines over this motor. They come from a north pole into a south, like that, and the whole field pattern is moving along like the magnetic river. Now, suppose we could sit at one place over the machine, such as in that little square, and watch the field lines go by. Notice the direction of the arrows. At the moment, the field is to the left. Now it's upwards, to the right, downwards, left, up, right, down.
Wheel.
So it's left, up, right, down. And the rotation, you see, is clockwise, which is to say, rolling backwards. So the whole machine behaves like a mechanical rack and pinion.
Holy smokes, chat. Wow. It's a motor. It's a motor, right? You realize, holy shit, magnetism is a motor. All it's just moving. And he said, okay, well, if you were to take it segment by segment, what was it? It was left, down, right, up. So, this may be backwards to you. I'm not going to bother with that, but you get the point, right? So just do left, down, right, up. And then imagine that's a wheel. And you'd be like, oh, now you can see why the wheel is going that one direction. That's why it spins that way. That's why it flows that way. That's why the ball spins that way. And you go, wow, okay. So this is also the basis for the right-hand rule in electrical engineering. How do we determine the vector of travel? Well, it's determined based on the magnetic field lines, the right-hand rule. Your magnetic field, they're all perpendicular to one another. So if you're confused by it, perpendicular means that they go like opposite like this, right? So they're all perpendicular in three-dimensional space. So we have two like this and then another one like this. 3 perpendicular. That's the right-hand rule. And then the right-hand rule will determine the direction of your vector. And that is the same thing that we're seeing happen here with why is it flowing that direction? Because the right-hand rule in electrical engineering. That's the reason why. So now, where's the plane going? I want people to stop asking me where the plane is going in the MH370 videos. You know the answer. I just gave you the answer. The United States government gave us the answer. Where's the plane going in this video? We have coordinates in the video. The coordinates in the bottom right of the video show the plane is flying to the east, generally to the east. Exactly. The plane is going backwards. The plane is going backwards. That's the correct answer, backwards. So the plane is flying to the east, and we somehow know, just based on science alone, the right-hand rule in electrical engineering tells us that this is an electromagnetic event. This plane is going backwards. How insane is that? We can tell just using science, looking at this video, because they left coordinates in the bottom left hand. This plane's going backwards. Therefore, it's going to the west. And we know those coordinates. That's the Nicobar Islands at 1840 on March 7th, 2014. That's Malaysian Airlines Flight 370. So where did it go? Somewhere to the west. Backwards. Next time somebody asks me where MH370 went, I'm just going to say backwards. In fact, that's going to be my answer from now on. Backwards. That's it. And then when they want more, they can come watch this clip. Okay, back to the spice. Back to the juice.
In which this is the field and this is the rotor. And here is the action. Well, of course, mechanical things are easy to understand. But when we make it magnetic, it's a little less obvious. But we put in a row of horseshoe magnets, and the action, as you see, is very similar indeed. This, then, we call a rack and pinion motor. Now, in a linear motor, a row of electromagnets effectively replaces the row of permanent magnets. And instead of the many-toothed wheel, I'm going to use a very simple wheel with just 2 teeth. When I switch on the motor, the wheel spins. And if I disconnect one of the wires to this motor, I can stop this traveling field dead. Like that. And now we can see the shape of it. There is the field shape. If I draw
That's really cool.
the wheel slowly along the surface, you can see the rack and pinion action in slow motion in the stationary field.
Okay, so if you were still special needs or whatever, and you still didn't get it, well, hopefully after that demonstration of the up, down, left, right, you understand why does it spin? Well, there you go. And then what's making it spin faster and faster? Well, frequency, the wavelength, frequency. How fast can you make it spin? Well, how fast can you hit it with the waves? How fast can you make the waves go? Right? So there's going to be another revelation as well. There's going to be several revelations that are going to come from this, guys. But what you see there with the magnetic part is extremely important. One more thing I wanted to say lastly on the MH370 thing is why do you need the fourth orb if you know it's going backwards? Because it can go backwards anywhere. How do you stop it? Backwards is just, well, what happens when I go through that wall? How far backwards do I go? Do I go around the earth a million times or, right? So you got to know when do you stop. And it's just a theory. It's just a theory. It could be wrong. Could be wrong. The only thing I'm really, really 100% sure about is that the United States government zapped MH370 with some orbs. Beyond that, I don't know. Apparently we got magic or some shit.
Now, if I reconnect, I shall start the field moving again and spin the wheel. Now, the rotary version of this machine is what drives an ordinary electric clock. It has a toothed wheel which moves inside a set of teeth on the stationary part, and I switch it on. There is a clock motor. Motors with steel rotors are purely magnetic machines because they don't depend for their action on any electric current flowing in the moving part. Unlike, for example, this copper cylinder. And when that spins, it does so because an electric current is caused to flow in the copper. And so I call this an electromagnetic machine. Now, by far the most intriguing magnetic machine for me can be made simply with an ordinary paper clip. First, I unroll it, and then wrap it around a pencil or other non-conducting rod, and then offer it.
Okay, so he just took a paper clip and wrapped it around a rod. Interesting. So let's see what that does. What was somebody else? Crap. Okay, yeah, never mind. Here we go.
To the linear motor. Now, this spins very well, as you see, and yet there is clearly no electric circuit, so no current can flow in the clip. Now, I want to distinguish very clearly between magnetic machines and electromagnetic machines. Both types are used extensively, both in industry and in the home. A washing machine, for example, uses an induction motor, which is an electromagnetic machine. Electric clocks, as we've just seen, are magnetic machines. Now, magnetic machines get better as they are made smaller, whereas electromagnetic machines are better as they are made bigger. This last fact I can prove to you in more general terms by using what I call my goodness models. Now, every machine has a magnetic circuit.
Chances of choosing a toroid as the model, pretty low. Okay, so a couple other things. It said electromagnetic machines get better as they get smaller. It really sounds like Eric Laithewaite was kind of onto the Casimir effect here.
Which I represent like this. The flux in that circuit is made to induce a current into an electric circuit which links it, like that. The force you can get from a machine is proportional only to the product of the flux in the magnetic circuit and the current in the electric circuit. So flux and current are the things you want lots of. The thing which stops you having as much as you'd like, of course, is the resistance in the case of the electric circuit and the magnetic resistance, or reluctance as we call it, in the magnetic circuit.
Okay. Wow. Okay. For my science nerds out there, hopefully you're paying attention. For my Star Wars fans and other aerospace engineers and aficionados, Chinese spies that are listening. So we want a lot of current. That's what he's saying. Flux and current. We want a lot of current. What limits us? Well, the material limits us. and the resistance in the material limits us. So the resistance in the material, well, what would be no resistance in the material? Oh, superconductivity, a superconductor. So it turns out, guys, superconductivity was important because superconductivity is it's both a byproduct of the technology, but also what enables it to be possible. Quantum effects at the macroscopic scale, superconductivity. So if we treat our plasma as a liquid that we can manipulate with magnets, that is a superconductive circuit in and of itself. We don't need a physical circuit. In fact, you don't want one because that's one of the limitations. The physicality of the circuit is a limitation, not a benefit. That's the reason why we can't pump up our current and our voltage. The circuit is the problem. We're trying to make it with wires and shit. Plasma, the natural way. That's the way that you create a circuit that doesn't have all the mass and all the restrictions of semiconductors. Semiconductors, bro. Superconductivity or bust, baby. Superconductivity or bust.
The resistance of an electric circuit is proportional to its length and inversely proportional to its area. So if I take a second electric circuit, which is twice as big in every linear dimension as the first, then its length will be twice as great, but its area is 4 times as great. So the resistance of the big circuit altogether is only half the resistance of the small circuit. And when we put the two circuits together to make our machine, the combined effect of the two is to make the big machine 4 times as good as the small one.
Okay.
So it seems as if the rule for electromagnetic machines is that the bigger they are, the better they are. Now, with purely magnetic motors, the rules seem to work the other way around. Let me show you what I mean.
Yes, for the uninitiated, it turns out the big secret is the universe is a donut. Everything works off of donuts. We should have just known all along. Donut is naturally the most delicious of all foods. But yeah, turns out it's real. Homer Simpson, he knew it.
These sheets are made of rubber, but it's rubber which has been impregnated with a magnetic material. And they've been magnetized.
Awkward use of the word impregnated.
So that the whole of that surface is a north pole, and the whole of that is a south. And yet, there doesn't seem to be any measurable force between them. They behave as if they were unmagnetized.
Wait, why are they behaving as if they're unmagnetized? Did he say why? Whatever.
But if I take some scissors and cut 2 pieces from one of the sheets, then we see how those behave. There's no noticeable repulsion, but at least there's some attraction. And if I cut smaller pieces still, then at once there's attraction, and this time there's even some repulsion.
Yeah. Look at it move. Look at that levitation right there.
Put one piece on top of the other with reverse polarity, and it just doesn't want to know the other one. So magnetic.
That right there, when I saw that, I went, oh boy. Chat. Again, okay, if you're thinking big, you're thinking, what year was that video filmed right now? You're going, wait, that was 1971? 1971, this guy's cutting up magnetic strips of cloth, and he's cutting them up smaller and smaller. And the smaller they get, the more powerful the effect is. What does that remind you of, chat? Does that remind you of microchips? That's kind of what you do with microchips, is you make it smaller and smaller and smaller and smaller. Have you guys not seen the video? I'll try to find it later of zooming in on a microchip to see how small it gets. It's just like layer after layer of getting smaller and smaller and smaller and smaller. That's what they're doing in microchips. Do you understand? This is what they're doing in microchips. This is why they're doing what they're doing in This is why microchips are the battle for anti-gravity and 0-point energy. Because you make it smaller and smaller and smaller, you make it perfect at the tiny nanoscale, and then you scale it back up again. Right? That's how you do it.
Things get better the smaller they are. Now let's apply this principle of size to our fascinating racking pinion motors. I'm going to put a plastic tray on top of my row of coils, and I'm going to roll along its surface some split steel washers.
Well, yeah, soon here it comes. Get ready for it, Chad.
A smaller one should go better still. Very lively.
I wish we had HD on this.
Now this experiment poses the intriguing question, just how small things can I roll?
Here we go.
Can I literally spin an individual iron filing? Well, the answer is that I can.
So excited.
And to demonstrate this, I'm going to cover the entire surface of the motor with iron filings. And switch on, and you'll see what happens.
Oh, chat. I'm so excited for this right now. I have to keep you guys in suspense. I have to tease you guys. I have to tease the ladies out there a little bit. You know what I'm saying, ladies? What's going to happen, guys? Who out there thinks they know what's going to happen when he turns on the magnetic river with a bunch of iron filings above it? Now, what's the point of the iron filings? The point is that the iron filings are going to line up with the magnetic field lines, so we can see what the magnetic field lines look like visually. Let's take a look. Waves. I'm hearing waves, cymatic effect. Let's see, chat. Now, again, I want to point out this video is from 75 years ago or 50 years ago. 50 years ago. And almost nobody in the chat knows the answer to this question. Are we being taught in school? Are we being taught in school, chat? I don't think we are. The fact that nobody ever taught me about Eric Laithewaite and what I'm about to see right now certainly makes me question why I'm not being learned more about magnetism. What the
Well, I don't know what you expected to happen.
I mean, just that didn't even look real. That doesn't even look real. It's an ocean of... Look at the ocean. You can see the waves flow. Look at that.
Well,
I
don't know what you expected to happen. I know
that is the coolest shit I've ever seen. Is there not a 4K version of that?
The first time I tried this, I certainly didn't get the result I expected. Look at the way the walls...
What? Bro, what am I looking at? This looks like some Pixar shit. This doesn't even look real. Those are iron filings lined up in like wafers. Chat, how is that real? How is that actually real? There's little gaps between them, like little discs. It looks like little wafers. Honestly, like I feel like I need to it's like bothers me. Does it bother anyone else? Like I don't like looking at can we brush it over or something? Why does it do that?
Walls are forming. Walls are filings.
You can see like the little waves in it too. The waves in it is just crazy. I gotta either find another version of this or clip this. This is just sick. So cool.
Spacing themselves from each other. The spacing between the walls depends on their height. So I can comb this lot like I could comb my hair.
Wow. Oh yeah.
All I'm doing now is flattening.
I don't know why that bothers
the filings down. And as I do so, they get closer together.
Wow, and then they just regrow back up.
If you look at an individual wall, you'll see that the bulk of the filings in it are actually at rest. It's only the ones around the outside which are moving. And they're pretty...
Wow, it's just like a river, right? So a lot of them are just at rest. The only ones that are moving are the ones on the edges. So when you look at the water, guys, when you're looking at the water, are all the water molecules moving? Or are they just standing still in a river? Are only the ones along the edges moving? It's a good question. Actually, a good question about what would the liquid flow look like? Laminar flow or whatever they call it.
Producing a gradual drift backwards along the field. Many of the experiments we've been doing with iron filings can be done with much simpler apparatus. For example, all you need is a horseshoe magnet and a means for rotating it.
Oh, here we go.
A plastic dish can be clipped over the magnet.
Full screen.
And then into the dish, we put a steel ball.
Give me some more.
When I rotate the magnet slowly, the steel ball just goes round opposite one of the poles. That isn't very exciting, nor is the fact that when I turn more quickly, centrifugal force flings out the ball to the sides of the dish.
Boring.
But if I rotate more quickly still, the steel ball will become a rack and pinion motor. There it goes.
Whoa, it just reversed direction.
Rotating backwards, steel ball will become a rack and pinion motor.
Hold up, chat. Who saw that? Okay, pay close attention to this. There's something magic just happened. Okay, it's spinning to the left. It's going counterclockwise. Boom. It just reversed direction. Oh, boy.
There it goes. Rotating backwards in the track.
I want to look at something for no reason. Just for no reason. Just want to look at something for no reason whatsoever here. Just want to look at when these orbs circle this plane. So do they do something similar to what we just saw with the spinning thing? Do they get their rack in motion or whatever the hell he's talking about? Okay, so they lock in here. And it looks like right there, right here, they kind of lock in. It's hard to say because they're in a three-dimensional environment. Like right there, it feels like they lock in and then they start their spin. I just want to look at that. This doesn't just, definitely feels like you can tell just looking at that, though, that magnetism is definitely involved in the movement of that. Magnetism is definitely involved. If you're not familiar with those videos, that's the MH370 videos. You can watch it on my channel if you want.
Traveling field.
That's crazy. It just spins around, though, and goes the other direction. Okay.
Let's put some iron filings in the dish.
Yeah, let's put some iron filings up in this bitch, chat.
Turn the handle and see what happens.
On today, chat. We're doing well.
And once we see the walls building up and the backward rotation.
Okay.
And something else.
Chat,
can you see the spirals of filings running up the hill into the middle?
Smoke. Why are
the inward movement of these filings?
Chat. Why are physicists so dumb? We're literally looking at a video of iron filings spinning around, and it looks exactly like a galaxy. And we're sitting here trying to figure out why galaxies form. Like, do you think maybe there might be a connection to magnetism? I mean, look, I'm just an IT guy that works in healthcare. I don't know about your fancy science mumbo jumbo. All I know is that space energy exists, and it's like all over the place. So they tell me that we can extract it and use it for stuff like making my dishwasher run, useful stuff like that. Taking the dog to the park. But I'm pretty sure that magnetism might be important. Like, we've now seen magnetism. We just saw magnetism spinning. Let me show the magnetism spinning one more time. Because now, guys, I have so many clips. Like, I can actually, piece the stuff together, you guys, in real time. It's pretty sweet, actually, if I'm not going to lie. Like, okay, I'm looking at galaxy.
You see the walls building
look at
up
this.
And the backward rotation and something else.
Okay, literally the galaxy. Okay, now I was looking at literally the galaxy. Now let's also watch this. I call it plasma in space. Blows me away. People are like, oh, plus I added this dope music. Boom, there you go. Well, look, there it is again. Oh, look, galaxy formation looks just like our magnets, iron filings. It's like, guys, how did we not figure out that magnetism was the answer? Gotta be. It's just like. I don't know why this makes me want to go to the club. Don't you dare disrespect space energy. That's my word. That's not your word to use. Only my people can use space energy. Okay. Let's do a couple more super chats, guys. I saw Sooty in the chat. Ashton, thank you very much, Sooty, for that donation for your I presume that's Australian dollars. Is everything upside down in Australia? I think technically yes. I'd like to invite you to join my Discord for building Bendini's SSG motor. It's simple build and only takes a few days once parts are sourced. Isn't the best disclosure of 0PE to build and demonstrate a motor yourself? Yeah, I mean, I don't generally endorse random stuff, but I would probably, you can shoot me an invite, take a look. And wish you the best of luck. Yeah, I think the magnetic motor stuff, I like it. I think it's cool. I want to have a magnetic motor in my office at one point, but my office will be for the build for my company that makes free energy microchips that goes in people's cell phones. I feel like that's easy $1 trillion. It's good enough. Mr. Rusty Rudder, the human body area network is whatever. I don't know. Was that the Wi-Fi numbers or something? Frequency? Would that be relevant to plasma? I don't know. I do think that there is. Someone was asking in the chat. Yeah, that was one of the earlier things people were asking about is what is the frequency? What is the special frequency? Answer is I don't know. If I had to guess, currently my hypothesis is that it's related to the 1 divided by 137. What's it called again? I don't know. Special number or something. Right. It is 137, right? Hold on, chat. There's so much to learn in physics, chat. I'm a humble IT man and sometimes internet troll. And you asked me to learn all of physics and electrical engineering. Fine structure constant is the answer, chat. I think it's related to the fine structure constant. Why? Because the fine structure constant is basically the source code of the universe. And there's some kind of relationship between the fine structure constant and the weird symbol that looks like a fish. I don't know. I can't remember it all off the top of my head. Too much to remember. But so my guess is that if you look at that, because really, what are we trying to find out? We're trying to find out what is the frequency of the 0 point energy so that we can tap into it. That's the point of why we want to know the frequency, because when we figure out what frequency, what standing frequency the background 0 point energy is at, then we know what frequency that we're trying to interact with. It helps because let's say, I'm going to simplify it. The frequency I'm looking for is 10, just 10. Well, how do I want to interact with 10? Well, I might try 5. I might try 20. I might also just try 10. Do you get the point? I'm going to try to match my frequency to the frequency of the thing I'm trying to interact with, ideally for best results. Now, that's the big mystery, which is, well, what is the frequency that we're trying to interact with? And my theory is that the answer is 1 divided by 137. For some reason, that ratio, like the ratio of pi, is one that comes up when you look at cosmology and when you look at quantum mechanics. Cosmology is not the right answer. Quantum mechanics. So, actually, cosmology is the answer too. So, never. Anyway, and I would also say for people who are looking into that, best of luck. And I think that's good research to look into. Also, take a look at cymatics, because it's not just one frequency is the answer. It's like you go through the frequencies and you find that at various frequencies, all of a sudden, harmonic coherent patterns form. It's noise, and then all of a sudden, boom, there's a shape. Like, what? Think about that. Think about that, guys. Okay. One more super chat, I think. Or a couple more. Truth Teller, early and Ashen Rants go hard. Hell yeah. And then one more. Speed of the river is much greater than the speed of the water. Seems like a hell of a euphemism for what? I'll leave it to the Laithewaite memes. Yeah, I think that for me, I think the thing to really break through to people is that we can ramp up these effects. If they seem small because the math looks like these effects are small, realize we can ramp them up and potentially amplify them as well. So we can not just scale them up, but maybe also amplify them. Pretty much solves all the problems that you have with thinking that the effects are too weak. Not to mention that guy just shot like a metal rod through a wooden fence. It's like, come on, man. That's just a backyard build from the 70s. Julio, if you I don't know. If you send blue algae, green algae to Mars and use plasma orb to accelerate the growth, it would kickstart. Oh yeah, I already solved this one. Sorry. Okay, here we go. Back. Oh, and then traverse magnetism sounds like one hell of a band. Yeah, and just okay. Spoiler alert. Basically, electromagnetism can interact with 0-point energy. That can manipulate gravity, and we can potentially stabilize plasmas. Did I miss it in here? He's probably going to say it right now, and I'm probably saying it too early, but I'm just going to say it right now as well, is that in one of these videos here, at least maybe this one, Eric Laithewaite says that the spin is potentially the secret to stabilization. The spin might be the secret to stabilization. So if the spin is the secret to stabilization, well then, yeah, just like we were reading into the force-free time harmonic plasmoids or whatever, they figured out how to stabilize these plasmas with spin, with waves, with frequency. Just like we're watching in this video. Like, they've just used this same concept in science, and they advanced it another 30 years, maybe more, 50 years, 100 years, however you want to think of the advancing the science, took it to the next level.
Can you see the spirals of filings running up the hill into the middle?
Wow.
The inward movement of these filings implies there must be an outward traveling magnetic field to produce.
Inward movement, chat. Inward movement. Now that should make you think of fusion as well. Inward movement. Why? Why do we need temperature? We don't need temperature. We can control the movement of the atoms.
And something else. Can you see the spirals of filings running up the hill into the middle? The inward movement of these filings implies there must be an outward traveling magnetic field to produce it. And if this is true, then it's very exciting indeed, because centrifugal magnetism, which is what this would be, is unknown at present. But if we turn the handle more...
1971. They had no idea what we were looking at here, how this works, why.
Slowly, and watch what happens in slow motion. We can see that the filings form into lozenge-shaped solids, and these are rolling over and over and spiraling into the middle, for the same reason that any rolling object
literally looks exactly like a galaxy, even with like the little extra rows like our galaxy has. Like, look at that. Where is it?
It's a lozenge.
Look at that. Look at those extra rows. Why is the galaxy? Why do our stars, galaxies have rows like this? Well, there you go. Why do we have planets? Different orbits. There you go.
Shaped solids, and these are rolling over and over and spiraling into the middle, for the same reason that any rolling object traces out a spiral on a flat surface. So we hadn't made a discovery at all. But of all the phenomena we observed with the iron filings, the most striking, perhaps, is the building up of the walls. It tells us, among other things, that when we make a rack and pinion motor, we shouldn't use a solid cylinder like this. We should divide the cylinder into a number of discs. These 6 steel discs have been spaced to match the spacing of the walls in the iron filing experiment. They are going to wind up this cord, and in doing so, lift a 2-kilogram mass. The discs will spin at 3,000 revolutions a minute. That is a lot of power to extract from such a small amount of material. In fact, that rack and pinion motor produces more power for its size than any other type of hysteresis motor. The shape of those discs is very similar to the shape of a coiled spring. At least it is magnetically. The most recent research that I've been doing has been concerned with rack and pinion motors of this kind, where we...
So, couple quick comments. One, we're not breaking any laws of physics. There's no new physics at play here. Isn't that a weird thing to say? This is why I'm saying that he says they're like, oh, well, when you look at it and you break it down, you realize, like, oh, there's no actual like new physics going on here. If you actually look at it in slow motion, turns out there isn't any new physics here. It's just that we haven't conceptualized the world in order to just accept what's right in front of us, literally right in front of us. And then he's saying, if you look at the force power of this type of effect, it's more efficient, more powerful pound for pound than anything else. It's extremely, now maybe that it's small. And then he also says a weird thing about, we want to make it slits because we saw the wafers. They were separated with these slits. He's like, we would want to make our engine also have those slits. So he makes the little spinning wheels have little slits. So it almost looks like a coil. Now, this is relevant because if you look at a lot of the free energy or extracting 0-point energy ideas, these are a lot of the ideas that uses coils like this, like a spring, things like that could interact with it.
Put a very small spring inside a glass tube because this could operate as a self-contained pump, a helical pump. This spins very nicely. And of course, smaller ones, being magnetic machines, operate better still. And I can spin this spring about 3 inches above the surface. Now, if I can develop these to the stage where they will be small enough to operate inside living tissue, then they could be very useful to the surgeon during operations. If this should be successful, then I'm never going to forget that it began with no more than a paperclip and a pencil. This, then, is the world of small motors.
Okay, you guys want to see something pretty cool? If I looked like I was distracted right there. So the other thing he said is you would want to make it into like slits, right? Like this. The moment I heard that, it reminded me of something. You know, I bring the receipts, chat. It reminded me of a Veritasium video that I saw once where he went to the world's strongest magnet. Interesting that it reminded me of this video. The world's strongest magnet, huh?
Rods. We then put about 20 tons of force on it and then lock.
Hold on. Oh, don't do
what you can do with a traditional wire wound electromagnet.
And that gives you like 34 Tesla down.
That gives you 33.5, but it's stacked up. So we stack all of these up in a stacking jig. They're aligned up with tie rods. We then put about 20 tons of force on it and then lock those tie rods down. And that holds the coil together. And
so it turns out the world's most powerful magnet, they're doing the same thing. They're making stacked sheets and they stack them on top of each other. Now, yes, you would say the distance between them is going to be very, very, very tiny, but it turns out that's more efficient. That's just better. They're like, well, why is it better? Well, we don't know why. Well, now you know why it's more efficient as well. It's more efficient because Eric Laithewaite showed us how the magnetic field lines flow. So we know that's why. Pretty cool, huh?
Now, I don't have to tell you that this is a big motor. In fact, in terms of diameter, it's one of the biggest made. Its rotor is this aluminium disc.
Wow.
So it's an induction motor, and therefore an electromagnetic machine. In spite of the fact that the moving part is rotary, it is a test rig for linear machines. Let's have a look at the driving unit. This row of coils is a linear motor which has been bent slightly to fit. Power on.
Start it up. Oh yeah, look at that bad boy. That's all a magnetic motor is.
But remember, whether it's a big, complicated piece of machinery like this, or if it's simply a paperclip and a pencil, in the world of motors big and small, the work you've just seen is only the beginning.
So you know what the biggest thing that surprised me the most here looking at this? It's pretty simple. But I just didn't know anything about it because I was too busy worrying about healthcare stuff. What? It's just a big pancake, big aluminum pancake, or whatever the hell that is. Spinning a big aluminum pancake through through a magnetic field, and that just spins a generator, and that's how we generate power. Yes, Ashton, that's how we generate power. Okay, that's literally it. That's it. Yes. Okay. Well, let me make one change to that. Wait, hold on. What if we add cavities in there?
Adding our variable inductor into the circuit, the capacitor only needs a minuscule amount of latent.
What if we add, instead of our wheel, we add little cavities, little ridges? So you see my little wheel over here? So in my wheel, it's not just a circle. It's got little cavities in it, little ridges. The secret to a lot of this, for some reason, is cavities. Cavities. You add a gap. So there's a gap you see in this right here. And what happens when now there's a gap? When we add a gap, we create a frequency. We create an oscillation effect. And what happens with the oscillation, then?
As even any dead capacitor will have some latent charge.
Oh, amplification of energy.
The process of exponential growth begins, and after a short amount of time, the current begins to take off. And since the current must be constant through all the elements, we see that the voltage across the resistor takes off as well. This means that real power is being generated in the system, and is able to do real work, creating heat through the resistor.
Wow.
Starting with a resistance above 165 ohms, we can see that the oscillation exponentially decays as more energy is lost than gained per cycle. As we drop the resistance below 165 ohms, the oscillation grows exponentially as more energy is gained than is lost per cycle.
So, a couple things you should understand from this. What did he just explain at the end there? Well, there's a level, the resistance, where above that level, you don't get exponential growth of current. Below that level, you do. Well, how much resistance is there when in superconductivity? 0. So everything is exponential growth, which is huge. Absolutely huge. Superconductivity is huge because it takes the bar and it just says there isn't a bar anymore. Exponential growth of energy, as much as your ball of energy can take. However much energy you can take, your system can take. And well, there's no physical systems that can take the amount of energy that we need, so they would melt. So the answer is plasma. So all we have to do is take our same exact system, our wheel that we're looking at right here. Add
through all the elements.
Add ridges to it. You can even see the up, down, left, right. Look at the up, down, left, right there. There it is. Okay. A couple other super chats. Tundra, thank you very much. Good evening, bro. Isn't this stuff amazing? Yeah, it is. But I think we're starting to catch up to be able to understand it as just normie people. But man, it's not easy. Okay. So that's pretty much the end of the first video. Now, the other ones, there's not too much more to get into, but I want to show you the big thing. Okay. So where's the one? Oh, where's... Oh, I didn't even have the one up that, sorry, one sec. Okay, here we go. Okay, so this is the big one, the gyro wheel. So Eric Laithewaite was looking at all this stuff. Everybody was loving him. And then he started going off the walls, guys. He was like, oh, so turns out I'm discovering something new, and in Newtonian physics can't explain it. And I think I figured out the secret to anti-gravity. He says, I think I figured out the secret to anti-gravity. And he does this presentation. Let's take a look.
This is an experiment with a spinning wheel, a rather large wheel, 13 inches diameter, mounted in a ball bearing on a shaft 3 feet long. I am going to hold it like this and swing it in a circle and lift it with one hand, but only when it's spinning. First of all, let me weigh it to show you just how heavy it is.
Answer is really heavy, Chad. Like 40 pounds. Basically, you're not living.
As I talk, you'll see that lifting it is quite an effort. It weighs about 40 pounds, and I can't lift it any higher than that without a lot of strain.
Yeah, is he worthy, Chat?
So now
you're going to find out he's about to become
we'll
worthy.
Spin it up to 2,500 revs a minute.
This old man's about to lift this 40-pound thing up with one hand.
Then I shall lift it 5 feet in 3 seconds by going around in a big circle.
So they're basically revving it up. They're making the wheel spin at the top.
Whilst I'm doing it, I shall talk to you so that you shall tell from my voice that I'm not under any stress of any kind.
Bro, that thing is spinning really fast.
Now,
Oh, you can hear it.
Go with my left hand.
If you mess this up, he could like really hurt himself.
The shaft only, I shall lift the wheel through 5 feet, all on its own with no effort on my part.
Look at him. He's a Superman. He's the Incredible Hulk.
All I do is apparently just to steer it along the path that it's already decided it would like to go.
He is worthy.
And there's the question of how you stop the wheel.
How do you stop the wheel? Wow. This is crazy. People didn't think this was real back then, guys. People thought this was some kind of scam or something.
That wheel has enough energy to throw itself 200 feet in the air. Did you notice that as it went round in a circle, there was no centrifugal force trying to pull my arm out sideways?
Huh. Yeah.
Let's just do it once more. At the same time, we've already spun it up. So here goes 40 pounds of wheel as light as a feather. This is not a conjuring trick.
Not yanking him anywhere.
This is a fact of science. Watch it again carefully. A fact about a spinning wheel that so far everyone has missed.
You know what's just so crazy about this? This is actually anti-gravity. This is actually anti-gravity. Because anti-gravity is stupid. And anti-gravity just means a force. Anti-gravity isn't magically shielding gravity. Isn't some magical force field around that makes gravity go away. It's not what anti-gravity. It's not how any of this shit works. We're not violating any laws of physics. We're just creating a force that counteracts gravity. That's all there is to it. That's it. The most efficient way to do that is to manipulate the 0 point energy itself and create a warp drive, and then you have infinite acceleration. But in lieu of that, any force will do. This is why I make fun of people, because if people are out there talking about anti-gravity or trying to make fun of anti-gravity, usually they don't even know what the hell they're talking about. They don't understand the basis for what we're talking about. Because if you think of anti-gravity as some exotic substance or mechanism, yes, you're always going to think that it's silly because your basis for it is a science fiction basis. In reality, anti-gravity is any force that negates the force of gravity, because gravity is just a pressure force. You would say, how do I negate going forward? Get pushed backwards? Is that a serious question? I don't know why this is actually so complicated. Once you realize that gravity is not a fundamental force and just an effect, then any force that counteracts it is going to be a counteracting anti-gravitational force. So yes, what we're looking at there is anti-gravity by that definition. Why? Because it's making that thing lighter for him to carry. We know that factually because that's an old man lifting up a 40-pound dumbbell on the end of a pole. You can just see it with your eyes and tell that clearly he's getting some sort of weight reduction effect on that. Now, how you explain that away and rationalize that away, that's up to you. But when I look at that, I can clearly see the physical effect of an old man being able to hold up a 40-pound dumbbell with one arm above his head, where no way in hell would he be able to do that otherwise. Okay, so to press home the point, undebunkable point, got another video. Again, to Veritasium. Veritasium recreated the experiment. I'm probably risking getting copyright striked here, but recreated the experiment. Here he is, 15 years ago.
Mechanical engineering shop has built this incredible piece of apparatus for me. It is a 40-pound, that is 19-kilogram flywheel on the end of a meter-long shaft. Can you imagine trying to hold this out horizontally with just one hand at this end? It is impossible. Okay? Now I'm going to let go. You going to be able to hold this at all? I hope so. Can you lift it out?
Look, this dude's jacked.
Horizontal. Hold
Look
it.
at this college student.
Come on, just try to. I want you to hold it out horizontal.
Even this jacked gym college student guy can't even hold this thing out horizontal, and he's cheating. And he's cheating the way he's holding it there. Does this dude even lift, bro, or does just these are fake muscles? Look at these fake muscles, bro. I could take this guy.
Oh, come on.
Can't even hold a 40-pound.
What I'm going to do is I'm going to spin this up to a few thousand RPM, and then I'm going to attempt just that, to hold it from one end and have it out horizontal.
Okay, so we know what he's going to do here. I'm just going to skip ahead to when they wind it up. Bro, this is dangerous.
With my left hand, what you'll see is that the shaft remains horizontal. You can see it going around there.
It almost looks as though the wheel is weightless. How does this work? Well, instead of pulling the wheel down to the ground as you'd expect, the weight of the wheel creates a torque which pushes it around in a circle. You may recognize this as gyroscopic precession. For a more detailed explanation, click the annotation or the link in the description to see my video on the topic. Here, I want to try something more extreme.
I'm going to try to lift it over my head with one hand while it's spinning.
Precession.
Wish me luck.
But before I make the attempt, Rod wisely suggests that I first check if I can lift the wheel above my head without it spinning.
Let's prove that I can lift it just this end.
You can't lift it above his head.
Careful.
Kind of can, but not really.
Spinning as fast as possible.
Give it 10 more seconds. 7, 6, 4, 3, 1. Oh, perfect. Now I'm going to release my left hand and holding only with my right hand at the end of the shaft.
Relax. Wait.
I'll try to lift it up over my head.
Wait for it, chat.
This is a 40-pound, 19-kilogram flywheel. Ready? Here we go. 3, 2, 1.
Yeah, easy. Look at that.
Beautiful. Let's go again. In 3, 2, 1.
Easy, chat. Easy money. Why is this important, chat? Why is this important? That's what everybody wants to know. Why is this important? Why? Because we're realizing
it feels incredibly light as I do that.
Spin is connected to anti-gravity. Of course, spin is connected to anti-gravity. Look at what we're looking at right here. We're watching spin give a weight reduction effect to a 40-pound weight. I don't care what direction it's going. We can control the direction of the spin. It's very easy to look at this and realize that if you can control the spin, then you should be able to control gravity, reduce gravity, defy gravity, whatever you want to think, whatever you want to call it. You're not really doing any of those things. Manipulate gravity, chat.
To lift it up, like it's a big effort.
To go up by itself. I bet if you left over
81 kilograms, which makes sense because the flywheel itself is about 19 kilos. That's 42 pounds. Now we're going to spin it up, and I want you to make a prediction. As I'm lifting it over my head, do you think the scale reading will be more, less than, or equal to 91 kilograms?
What do we think, chat? What do we think? I know my guess. What do we think, chat? More, less than, or equal to? Interesting. Well, I'm going to go less. I'm going to go less. It could the answer could also be equal. It's certainly not going to be more. Let's see.
Grams. What do you think? You can make your prediction by clicking on one of the on-screen annotations, or if you're on mobile, you can click a link in the description. 5, 4, 3, 2, 1.
Where's this video? Wait. Oh, did I just get debated into another video?
Standing on the scale.
I got debated.
What do you think?
I don't know about you, but to me it looked like a shaky mess. Let's watch that again in slow-mo, and I will graph the scale readings.
Yeah, it went down to like 70 for a second. His foot might have gone off the thing.
As you can see, during the lift, the scale oscillates around 91 kilograms, the same as it read when I was stationary. So it seems the apparatus doesn't get heavier or lighter when it is lifted while spinning. The only large deviation from the average comes at the end of the lift, when I let the wheel fall so the scale reading drops. And then I slow its descent, and so the scale reading rises. So the question remains.
So, I was actually going to say, you guys are not even watching. I had the video up in the background. Okay, well, my bad, chat. Look at me. There it is. I was actually going to say that my guess was equal. Why equal? Why equal? Because the answer is you can't actually manipulate mass. You can't actually manipulate mass. But you can, at the same time, change the local effect. So this is the part that's tricky. You're not actually changing the physical mass of the object, but you can make it so that it feels like it's lighter. And that seems counterintuitive. So let me see here. Maybe and who knows, maybe I'm full of shit on this, but for some reason, this reminds me of the Eric W. Davis clip where he says about reducing inertia.
How do you reduce inertia or modify inertia?
You reduce or you modify inertia by changing the 0-point energy all around you. That's the answer.
It's a resistance to a change in motion, which we quantify as a proportionality constant between an external force and an acceleration. So what are you reducing?
A few moments later.
The RHIC experiments give you the idea that if you can modify the condition of the quark-gluon vacuum state,
right,
then you can modify the mass of the baryon.
So it's not about modifying the object. It's about modifying the region around the object. So the bigger question to me is, when it's spinning, what is happening? What is happening? Why is spinning doing anything? So here are my thoughts, and I'm happy to take criticism on this. This is my thoughts as a healthcare IT normie guy. Is many people figured out that spin was a factor And we know that because when you look at Eugene Potklinov and Ning Li's research into YBCO superconductors, did I say the acronym right? You realize they were using ceramic superconductors and they were spinning them. And they were achieving a weight reduction effect. Well, what they were achieving was they were doing whatever the same thing, presumably, that Eric Laithewaite. They were seeing the same spinning magnetic effect, centrifugal effect that Eric Laithewaite was seeing. Spinning a superconductor. Yeah, exactly. As phase material research just said. Now what would happen is if we phase... So now we're actually able to see the timeline here. Eric Laithewaite was looking at this in the 70s. And then in the 90s, Ning Li, Eugene Potklinov said, oh, what happens if we spin a superconductor? A perfectly conductive, like, repels magnetic fields away. What would happen if we do that? Would that produce anti-gravity, quote unquote? The way I look at it is we're churning up the ether. We're churning up the ether. And what is a magnet? We answered what a magnet was last week. A magnet's just electrons. Electrons are magnets. So when we look at a bar of magnets, all the electrons in the magnet are lined up. They're all lined up, ready to go, creating an efficient, permanent magnet. So magnetism is potentially one of the keys for us to be able to interact with this 0-point energy that's all around us all the time. And if we spin a magnet, then it's potentially churning up this ether. And that's why we would see these effects, because it's distorting space-time on a probably small scale, but distorting it at some level of some scale. And that's what I think we have happening here with these with this spinning metal disc, why we're seeing this precession effect. Now, the Action Lab had another video, and I'm going to show theirs real quick, or at least the first part of their video. And I like the Action Labs. So they make this wheel.
Gravitational energy. And is the interesting thing about reflection of the scale, time this is bobbing up and down, right around there. But you can see that if I shift it around to see the energy gets converted between potential energy and kinetic device. So as I lift up on the wheel, you can see the weight go down. It goes negative. Wheel. I'm going to hold it at the top. Now watch what happens when I release it. It says -6 grams. And it literally stays at -6 grams.
Yeah, wait.
The reason when that wheel starts spinning, it's the equivalent. When he spins up the wheel,
Here we go.
This is gram force. We're not measuring the mass, we're measuring the force. So 1 gram on here is the force that 1 gram would put on the scale. So for some reason, when that wheel starts spinning, it's the equivalent of removing about this much mass from the wheel. That's a significant amount. That's around 1% of the mass of this wheel here. When I first saw this, it brought to mind a famous video by Eric Laithewaite at the Imperial College. In this video, he shows that he has this 40-pound negative because you're kind of shifting the weight all around, but it doesn't keep an average lower weight. But as soon as I get the spinning, even if I don't do it very high, just around, let's just start it around this high. As soon as it starts spinning, it drops to this -6 grams again.
So I'm not a huge fan of this experiment. I just think this experiment doesn't really do what he's trying to do. But the reason why I wanted to show this video is this part right here with the gyroscope. He tests the gyroscope.
Change. So why is it that this wheel weighs less, but this one doesn't when it's spinning?
So the gyroscope, in his view, doesn't seem to work, but I don't really know if I like his example that he produced here with this.
So how is Professor Laithewaite able to lift this heavy weight over his head? He was actually...
And so basically, I'm not going to dig into the whole thing, but he basically says that, well, you know, the physics says that, okay, from the force perspective, it does make sense why it's going to weigh less from just a physical force perspective, but from a mass perspective, the mass of the object hasn't actually changed. That's pretty much what he explains in the next. Somehow it takes him 5 minutes to dig through that. So there you go. So I wanted to show that, and then let's see if we have time for one more. Okay, and then I think we're just going to show this other video, which is this guy goes ahead. He's like a big fan of Eric Laithewaite, and he builds a device. Okay, I think his name is Alex Jones. Not the Alex Jones you guys talking about. Here we go.
When Sandy Kidd goes out to the lockup garage behind his house in Dundee, he is going into a
Sandy something or other. I forget what his name is. Chat, what's his name?
World of his own. This place has been his prison for the past 4 years. Here, he has spent every minute building a machine. A very special machine. A machine which he says will open up the universe.
Right off the bat, we're seeing spin, right, Chat? Quite interesting.
What I really wanted to do, I suppose, was to create the means of powering a flying saucer, that somehow I could put a machine together using gyros in which all our energy could be properly harnessed to produce a lifting force or thrust which would be capable of driving some sort of craft through space.
Okay. Well, I mean, that's very specific. It's like, oh, I was trying to figure out how a UFO would fly and how a craft could fly through space just spinning stuff around. So essentially what we're going to see here is he created one of these devices that shows there's a lift, and he got Eric Laithewaite to look at it. And Eric Laithewaite was like, oh, wow, yeah, this actually looks legit. Like this device does look like it's producing anti-gravity. Is that Sean Connery? Could be.
Family to such
person. He never was.
His wife, by the way, was like not too pleased with this. It's pretty dated. I'm not going to lie to you, chat.
That flying saucers are real and are used to transport the inhabitants of outer space between stars and planets.
It's interesting to see how the stigma has changed around aliens, where they're like, flying saucers are used to ship people from one place to another. Like, Jesus Christ, we were so dumb.
These magical machines are streaking across the heavens of the universe. Then one thing is certain: their technology is far advanced on anything we are using at the moment.
My machine should be able to deliver thrust motor car.
Turning 25. This gyro weighs 50 pounds and has been fired up to rotate at over 2,000 revs a minute, so that Professor Laithewaite, an expert on the subject, can demonstrate the as an international authority on electrical engineering. The professor's know-how in gyroscopes has always led him to believe in the concept of a machine like this, a device based on gyroscopes which could produce a genuine lifting force. When he saw Sandy's invention create such an effect, congratulations were in order.
That is fantastic. There can't be any doubt. I mean, there's a whole object that goes up. By whatever means, it goes up.
Is he the first person to have done this?
No. Others have done it, and inevitably have modified their machines to try and make them better, stop them from working, and they've never been able to recreate the original machine. I've had several like this.
So how does Sandy Kidd stand then?
Well, he didn't make the mistake of meddling with his first machine. He kept it, so that when he made a second machine that didn't work, he said, what's the difference between this and my first machine? It's only the first machine made better. Then he realized he'd lost some of the flexibility through the rather loose engineering of the first machine, and was able to see what it was that was making it go.
Interesting. So the other thing as well is that realize a lot of people ask me, Ashton, why don't you go make something yourself or what have you? And I just kind of laugh at those people. Like, I always know when someone's really asleep when they're like, Ashton, why don't you go build this or do this? Well, because everybody's already done that before. I'm trying to do something different that other people haven't done before. Nothing's ever really worked. And I also don't like to do what other people want me to do. I don't know, maybe just call me a rebel at heart, but I like to just do my own thing. So that's the reason why I don't. And because I look at all these videos of people who've done it and how hard it is and how many this guy put 40 years of his life into this for what? What did he really achieve out of it? A 15-minute YouTube video? I can do that one day. And that's just the harsh reality of what we're dealing with here. What we're dealing with here is a thankless job, thankless work for a lot of these engineers. And they've been not getting thanked for their work for decades, many decades.
So then he's been able to make a better machine, knowing what it is that makes it go.
Upwards and taking the machine with them. Because of its design, it is only able to rise 2 inches off the bench, but the machine is capable of climbing to any height you want. The machine produces a thrust equal is called centrifugal force.
Engineering. Wait, right? I'm pretty sure the right-hand rule in electrical engineering, know it applies here, right? So that should be the direction of travel of thrust.
With the gyros themselves being driven at a very high speed in a certain direction, they react to the centrifugal force by swiveling upwards and taking the machine with them. Because of its design, it is only able to rise 2 inches off the bench, but the machine is capable of climbing to any height you want. The machine produces a thrust equal to 10 or 12 ounces, but the
so basically, you can see he basically created a machine here that's going to lift. If there's lift going up, it's going to allow it to lift going up. That's basically what he created here, and it does it. It works. You can do it. So the question is, it took all that work to get 2 inches off the ground, where people are just going to say, yeah, well, some other explanation. It was just vibrating a lot or something, right? This is the other problem. Is that this guy made a device, wasted it, spent his years, whatever, and basically got nothing out of it. I mean, maybe he enjoyed it, and I thank him for his work. Don't get me wrong, but it never changed anything. Nothing ever really changed. Now, what I would point out is that was 50 years ago, and technology's gotten a lot better. This is the reason why microchips are the answer, is that everything you're seeing here, we figured out how to take a literal gyroscope and put it onto a microchip. This is not a joke. Go look at the history of gyroscopes. Gyroscopes were used for autopilots on airplanes, and they put it onto a microchip. That's the same thing that you can do with that device that you just saw. So if you can take a device that can do anti-gravity, like what you just saw or being demonstrated here by Eric Laithewaite, Sandy, etc., and you can make it more powerful and scale it down onto a microchip, now you can produce a microchip that can shoot a gravity beam at you, manipulate gravity, which was, thrust. And that's huge. Yeah. And for the people who are saying, making comments about the implications of this and the revelations of it, yeah, it's gigantic. That's why I post about it every day. I'm just waiting for people to wake the hell up. Look at all this science and people out there that have researched this. I didn't know who any of these people were before all of this. I didn't even know who Eric Laithewaite really was before I started researching him. There's one more video, but I don't think we're gonna have time for it. But there is one more, which is actually the namesake of today's thing, called the magnetic river. But it just kind of shows more about how the magnetic river is functions. Actually, let's watch one clip. Because I actually see the waves here. I want to see the traveling magnetic field here. Here we go. One more clip for tonight, chat.
How does all this work? Could I have the row of rods, please, right? This is a mechanical model of what you've just seen. Instead of a row of coils, we've got a row of rods. We're going to feed them with alternating current so that each one can rise and fall. And when we turn the whole thing, we get the impression of something traveling along. But I want you to notice that nothing actually travels along, because each rod only moves up and down. The thing that makes it real
is when we put something into one of the troughs of the wave. Then something real travels along, can make it go the other way. If you watch an individual rod, such as this one, you'll see that it's only going up and down. There is no horizontal movement at all. Only the ball is a real thing moving side to side. It's exactly the same with this magnetic river. I can switch.
If you did not understand that clip right there, then you need to keep watching, chat. You need to keep watching. The waves, the electrons aren't moving in your wire. The electrons aren't moving down the wire to get to power your power plant. What's really happening is that you are stimulating the ether, right? You're stimulating the ether. This shoots up, then this shoots up, then this shoots up, and this shoots up. It looks like a movement to us because it forms a wave over time. It's exactly the same phenomenon as watching the wave in a football stadium or a sporting event. When you're watching the wave in the sporting event, the fans aren't running around with the wave, but it looks like a moving wave because of the time when the people are standing up. Imagine the 0 point energy all around you is the same exact way. That's what's happening. That's what he's saying is actually happening, is that you're not actually seeing the movement of the electrons here. What you're seeing is this illusion that looks like movement because of the relative stimulations of these electrons from potentially the 0 point energy. Now, let me connect this to one more physics theory, which is the Dirac hole theory. The Dirac hole theory is quite beautiful. This idea that there's this 0 point energy all around us, okay? All the energy we're seeing around us, the energy is coming from this light right here. It's coming from that 0 point energy. And the idea is all energy that we see visually around us has been pulled out from the 0 point energy field. And it exists temporarily in our reality. And it leaves behind, when you do that, a hole. So it's like scooping that energy out and pulling it out. The same kind of idea. That's conceptually how I think we should be thinking about magnetism, energy, 0 point energy all around us. Okay, let me see if I got some last comments here, guys. So I think here that one of the big clues that we should have taken from this was that magnetism is invisible. So we should have also thought, well, is there a magnetic substrate like the ether, 0 point energy all around us as well. The idea that, oh, well, we can't see the ether. It's hard for us to measure it, therefore it's not there. That's crazy. That's crazy. We can't see magnetism either, but we know it's there. We can see the force of it. We can see the effects of it. We can see the Casimir effect. We can see the Lamb shift. We can see the Aharonov-Bohm effect. We know the ether is there. Just ignoring it doesn't get anything done here. The number of people that know about this science is potentially very small. Is another thing I'm realizing. It's a very small number. In fact, I might have alone, like the scientists that understood this to be real, basically an endangered species. This chat alone, this live stream alone might like quadruple or quintuple or like 10 times over the number of people that even understand this science on the entire planet. I mean, I'm not saying that people aren't capable of understanding it. I'm just saying people that understand it and believe it to be real. There was also a point during that video where he talked about a helix pump. I believe it was Robert M.L. Baker, a Lifetime Achievement Award for High Frequency Gravitational Waves, that mentioned some type of helix formation to create a magnetic motor. Two last things, guys, and then we're good for tonight. And yes, I would appreciate it if you guys hit the like and subscribe and share with your friends if you enjoy the content. The rest of the week is going to be about MH370. I saw a lot of questions in the chat. Save those questions for the other live streams, and then I will address them. I guarantee it. First thing, I'm realizing that I'm going to have to learn about academia in order to really dig through this. I'm also realizing that academia is a big shit show of politics, just like all the other communities have been up to date that we've interacted with. And I'm seeing Sabine going at people and what have you. Normally I wouldn't give a shit about academia. I couldn't care at all. But the more I've looked into this science, the more I realize they've got the same thing going on where all the answers are all there right in front of them. And they've just been kicking themselves in the face over and over again instead of just, getting the answers. So we're probably going to have to dig into the history of academia, who was beefing with who and what have you. So one of the next streams is probably going to be looking into Lorentz, and because he was a strong proponent in the ether and he basically just got railroaded by people. And so we're going to dig into the nuance of it where he might have been wrong, but also right at the same time. We're going to get into a lot more of that. Last thing, guys, nobody called it out yet, but I promised you there would be something back here. And there is not. So the update on what are we going to call it? Entertainment Center Gate 2025. I did do some research into getting a new piece for the background here, and I narrowed it down to 3 pieces. It took several hours, and I engaged a consultant, also known as my mom. I engaged a consultant, a woman, to tell me, what would look good, what have you. And so I've narrowed down to 3 pieces. I am going to get that ordered and delivered. So eventually in the next week or so, there will be another piece here. I want to thank the donors and donations and all the super chats that have helped to improve the production quality. Okay, a couple of last super chats. Matt, thank you very much. Not sure I agree on terms of spinning the gyroscope versus gravitational forces, but I do think that toroidal shaped plasma balls, toroidal shapes are definitely important. Also, I think the heat signature in the MH370 video orbs is probably related to the toroidal shape of, like, you imagine a toroid and things being sucked into a toroid, it would create kind of an umbrella. That's probably why we see that umbrella shape. Interview John Carmack. I have no idea who that is, but thank you very much, Justin, for that donation. One more. Please inform members of the Insane Clown Posse about magnets. Yes, please inform them, guys. It's very important to educate people. I think it's funny that ICP might be right, that like people really didn't understand magnets, like quite literally didn't understand them. So, okay, guys. Okay, guys, that's it for tonight. Thank you very much for the live watching tonight. I hope you guys enjoyed learning about magnets, magnetic motors, and potentially the concepts for free energy. We will be back on Wednesday. It'll be a all evidence review live stream. All evidence review, MH370. Going to get the case to the Arrow submitted with all the new evidence. And then on Friday, I will go over all the theories about whisper data and pilot suicides and teleporting planes and what have you. It's going to be a great week, guys. Check out the content. Share with your friends. Peace out, MH370X. Love y'all. Later. Okay, let's go with this one.
Infrared eyes, scanning the black, tracking the heat, never turning back. Control 22, a covert gaze. Control 33, in the cosmic maze. Controls in the mix, secrets untold. Silent watchers, brave and bold. In the shadows, they silently glide, protecting our interests, far and wide. Spears, sentinel of the night, watching over with infrared sight, alerting us to threats afar, guiding our defenses like a guiding star. In the silence of space, they keep their post, shields unseen yet feared the most. With precision and speed, they warn of danger, keeping us safe from the missile's anger. As Beers, sentinel of the night, watching over with infrared sight, alerting us to threats afar, guiding our defenses like a guiding star. And he rolls in the mix, secrets untold, silent watchers, brave and bold. In the shadows, they silently glide, protecting our interest far and wide. As fears, sentinel of the night, watching over with infrared sight, alerting us to threats afar, guiding our defenses like a guiding star. As fears, sentinel of the night, watching